Good morning, boys and girls, and welcome to the Stink Bug Works. As you can see, there are batteries being charged. What could that possibly mean? Who knows? There might be a special bonus feature this afternoon. Now, back to our regularly scheduled programming. Big B was talking about props. And Big B, here we go. Big B had some really aggressive props on his twin catamaran, and he's looking to get a little more speed out of it with a little or at least the same speed and less load on the motors. And here is my advice to Big B. There's no free lunch. Every time you mod something, you lose something. Now, sometimes it's not a big deal. When you take an X series prop, I don't know if that's in frame. I have a new camera mount, so I don't know if it's in frame. When you have an X series prop, it's got a sizable tongue. And what happens is the pitch varies across the whole propeller. So the pitch here is small, but then out here, the pitch is big. As this blade is rotating and leaving the water, it's giving its maximum push right there. But then right here, simultaneously, this edge with the minimum pitch is digging in and slowing things down. Now for accelerating, that's a good thing because you're grabbing that water. When you're up at high speed, you don't want to be grabbing it. You want to just be, So that's why they take these off and develop the M series prop. You see the slight difference? This is the ever-popular M447. And some guys take them off even more to where you get this kind of appearance. It's still the same prop. It's just that's been removed. This will give you higher speed, but what you lose is that out of the hole acceleration. So everything's a trade-off. That's what I'm telling you. Everything's a trade-off. This is an N series, as in November. This is the ever-popular N940. It is essentially a reduced blade area as well as cutting some of the tongue off. Big B's thinking about going this way. These work really well on some boats. On other boats, they don't work for beans. So you're going to be getting advice from a lot of people that are saying, oh, do this and do this and do this and do this. Take everybody's bit of advice with a grain of salt. Think long and hard about it. You've got that logical mind. You can figure out what the water is going to be doing, and when you change the shape, what the water is going to be doing then. You can figure that out. Then, and Jay Turner wrote the book on electrics, and you might have to apply his theory when modifying props, and applying his theory can be a bit of a pain in the ass and the wallet. His theory goes like this. Somebody asked him once, shortening rudders, how do you know how much to shorten a rudder to get maximum performance? And he would say, well, I'll just keep cutting the rudder until I cut too much off, and then I'll buy a new rudder and I'll cut it off just before So what he's saying is, you throw away one or two before you get it right. Just a word of advice. Can I tell you what's going to work better? No, I can't really tell you. You know, back cutting, you mentioned back cutting. Back cutting, really just in your mind, think of it, it's just changing the overall rake. You know, you still have this little corner hanging out, but it's now more of a line between here and the tip rather than here and the tip, if you follow what I'm saying. So this portion of the prop doesn't do any work anyway, and it does tend to unload things. So you could give that a try, but you can never cut more material back on. If you follow what I'm saying. So you can cut this off, and if it doesn't work, well, then there you are. But that's part of being a test pilot. Thin to blade area ratio. That's why these 9 series props were popular. They didn't put as much load on your motor, but you had to have a hull that could take advantage of that. So you may have a hull that can take advantage of it, although depending on its weight too. So we'll have to see, but you may go through quite a few props before you get the combination that works. Anyway, there's my 2 cents on props. Without saying anything, I've just said, go slowly. Until next time, jet out. Good morning, boys and girls, and welcome back to the Stinkbug Works. This morning's topic was propellers and detonguing an X-Series propeller and comparing the difference before and after. And part of the process involved balancing. Now, Big B prefers this balancer, and I have to agree with him. This is a really good balancer. I mean, it only has one shortcoming that I have found. It doesn't do little tiny props very well. This one from Robart is a similar design, but I find the Dubro one to be far smoother and less friction. They all operate on the same principle. There's these large, low-mass wheels that have a very minuscule bearing area, so there's very little friction to rotate those wheels the small amount they need to accommodate this shaft. But again, a small prop, there's less mass in a small prop than there is in those 2 centering bushings. So they work well with bigger props, but with the little tiny, especially those aluminum props, God, those things are so hard to balance. One of the best balancers is one of the oldest. And to get this thing to work well, you need to take your balancing shaft, it comes with a whole bunch of balancing shafts, will roll on these 2 shafts, and I always like to buff them up with a little bit of steel wool just to get. But you can see where even this shaft is somewhat out of balance. You can see how it'll, it's a good balancer, but it's a pain in the rear end to set up. You gotta You got 3 screws. You got to level the whole thing. It's tricky. But once it's set up, it works really well. Then they have the magnetic balancers. And I think the first one out was the Top Flight. And I got one of those, and I made some extra parts for it and had some telescoping tubes for some reason. And so this was one of the first magnetic ones, but the shaft was too long to do a good job balancing small props. I find that small props, the shorter the shaft, the less rotating mass you have, the easier it is to balance them. These just have too much rotating mass to be able to balance those props. Any little imbalance in the prop is insignificant to the mass of that. So the lighter the whole thing is, the better, which is one reason I like these. They use a small shaft and then an aluminum shim up to size. And the cool thing about this is, when you're balancing your props, okay, when you're balancing your props, and you can see this one's a little out of balance, you can take this off, put it in this tool that has a notch. You can see where it's been buffed a little bit in here too. And that will hold your prop while you work on it. You know, you get your file in here and you work on it with your file. And then you see what I'm doing here too. You don't want to let these points slam into the magnet. So I protect the point and then, you know, gradually let it hit there. So again, you know, and with these, I always rotate the shaft a little bit because sometimes it is different. But what I really like is this. And I went online today and I can't find these. They don't exist anymore. So if I were king for a day, you could use a file handle and just make you could maybe even use a coupler. You follow me? Use a motor coupler, put it into a file handle. This would go into one of the grub screw holes, and you could file, if you want, a little drive dog to hold your prop. And that way, you could build one of these. Just thinking out loud here. One other tool I made that works really well is this little guy here. Now, this little guy and this little guy are one. And so what happens, how this works is, this was an old 1/8 straight drive shaft, and I flipped the drive dog around. And that way, I can take my prop and put it in this way, back it up with a little bit of fuel or cooling line tubing, whatever you want to call it. And there, your prop's in there, but it's not it's not locked in, so to speak. If you hit something, and you'll see what I'm talking about, hard this way, it'll allow the prop to move back. So what I do with this contraption is I chuck it up in the lathe, and then in the tailstock, I take this hex bit that's been fitted with a ball bearing, and I'll go ahead and support that end of it. So then, as the prop spins, can you see? It makes kind of almost an M shape. As this tongue comes along, the shadow of it would make an M. You follow me? Can you see that? Well, you break out your file, your trusty file, and as this thing's spinning in the lathe, you gently, very gently begin to file down the shape of that M. You're working on the tongues. You want to be cutting the tongues of that M off. And so you very gently with a file, it'll be going brrrr. But if you spin it fast enough and you take smooth enough little cuts with a file, pretty soon you can shape that M shape into kind of a cup shape. And you can control how much tongue you take off. If you want to reduce some blade area, you'd cut it here, and you're just using a file. So as this thing's spinning around, it's spinning this way, and you're just kind of filing it, and it's kind of going brrr, brrr, but you're just kind of gently filing it, and then you can break out the sandpaper and sand it and kind of get a nice even. See, the whole point of that is the blade shape will be the same. It's in the box titled Need Work, because once you've got it to shape, you still have to come in here and, reshape all this and balance it and so forth. So anyway, you know what changing this will do. You've seen what that does. Here's one preferred method. This, for my tiny stuff, is my preferred method. With the big props, this is good. But with the little tiny props, not so much. Until next time, boys and girls, jet out.